Welcome back to part 3 of 5.8, 5.9. So now we're looking at example E. So we have f prime of x. Is the graph right there we're given. And then again, we're trying to see which is the possible graph for f of x. So again, we're going to start off with analyzing our graph of f prime. And again, you guys want to, first of all, like check where is it, what could tell us whether the f of x is increasing or decreasing. And remember, that is the first derivative test, right? So if you notice here from negative infinity all the way up to negative 5, f prime of x is less than 0. So we can say f prime of x is less than 0 on the interval from negative infinity to negative 5. And again, this has the implication that on f of x, so on f of x, that means that the function is decreasing on that interval. Well, let me write the interval. So on negative infinity to negative 5. And then after that, we notice that f prime of x is greater than 0, right? When from negative 5, it's greater than 0, and then it reaches 0 at positive 1. And then again, it continues back up on that uh, above the x-axis. So we're going to say that f prime of x is greater than 0 on negative 5 to positive infinity. But we have an exception, so except at x equals 1. And then we can say that briefly, right? So that means that f of x is increasing on the interval from negative 5 to positive infinity. And now there's no more we can do with the graph of f prime of x. So now we're going to start looking at the second derivative. So let's look at the second derivative. And remember, that's just the slopes of the lines here, right? So if you draw a bunch of tangent slopes, that's pretty much what the behavior of f double prime of x is. Okay, so first of all, we're going to say that if you notice, f double prime of x is increasing from negative infinity all the way up to negative 3. So we're going to say it's greater than 0 on the interval from negative infinity to negative 3. And also, right, because it also keeps increasing. So it decreases from negative 3 to positive 1, and then it starts to increase after 1. So at 1 comma positive infinity. And again, this will mean that f of x is concave up on those two intervals. And 1 to positive infinity. And then f double prime of x is less than 0 on the interval from negative 3 to positive 1. So we're going to say that f of x is concave down on that interval. And then finally, we're going to see, again, we can talk about our relative maxes or mins, our relative maxima or relative minima. So we're going to say that f of x, because again, f prime of x changes from negative to positive at x equals negative 5. So that's our critical value, right? Because it's crossing the x-axis. And it stays from positive to positive at positive 1, right? So in this case, we're going to say that f of x, because this is the only place where it changes sign. So that means there's only one. In this case, it goes from negative to positive. So that means it has to be a minimum. So f of x has a minimum. Oops. Minimum at x equals negative 5. And then we're going to say it has 2 points of inflection, right? Because again, this is where f double prime of x is equal to 0, right here. So This is where f double prime of x is equal to 0. This is where f double prime of x is equal to 0. So we're going to be saying that f of x has 2 points of inflection. And then one of them is going to be at x equals -3 and x equals +1. So now we can make the graph for, with all the analysis, we can make the possible graph for f. So again, we have a minimum at x equals -5. So that means that's going to be a low value somewhere here, right? And then it has a point of inflection at -3 and another one at +1. So we're going to draw this one somewhere over here. So again, this graph has a minimum, so it might be coming down from negative infinity when it reaches -5. And then here, it's a possible, it changes, right? At f double prime is concave up. It's concave up from negative infinity to -3. So that means we're going concave up here. And at 1 to positive infinity. So we actually change concavity when we reach -3, right? Because it is a point of inflection. So kind of like this, I would say, pretty close to it. And then finally, it's concave up when it reaches 1. So it'll probably go like this. It is a weird looking graph, I have to say. But that is pretty much the possible graph for f prime. So again, it's concave up from negative infinity to -3. And then it changes concavity. This is supposed to be like concave down from -3 to +1. And then again, it goes concave up from 1 to infinity according to the analysis. All right, so now let's look at f. And then on f, so again, we're going to start off with our analysis of f prime of x, right? First of all, where is it negative? Where is it positive? So we're going to say f prime of x is negative less than 0 from negative on, right, on negative infinity, and then when it reaches -1, essentially. And then this means that f of x is decreasing. F of x is decreasing on that same interval from negative infinity to -1. And then we're looking now at when is it positive. So f prime of x is positive on the interval from -1 to positive infinity. And then again, that means that f of x is increasing on that same interval. -1 to positive infinity. And now we're going to start looking at what's happening to the graph of the slopes, right? The tangent slopes. So for f double prime, so what's going on with the tangent slopes? It reaches 0 here, and then it keeps going back up, right? So we're going to say that f double prime of x, right, because this is the second derivative test, is greater than 0 on the interval from, in this case, it's always increasing. So we're going to say negative infinity to positive infinity. So that means that f of x will always be concave up, is concave up on that same interval from negative infinity to positive infinity. So from there, we're going to look at what's happening to f of x, where does it have either relative extrema. So in this case, we're going to have f of x has relative extrema at -1, because that's when it changes from positive to negative right here, right? From negative to positive. So that means that we have at x equals -1, f of x has a relative minimum at x equals -1. And then here, there is no place where the slope of f double prime is equal to 0. So we're going to say that f of x has no points of inflection. All right, so we have a minimum at -1. So we're going to draw that right there. And again, it's like decreasing from negative infinity up to that value. So we're assuming it's like a wide parabola. And then it starts to increase, and it's always concave upward. So it's not a quadratic, but it might be a quartic function. That's why we get this type of graph, right?